Hey guys, welcome to this session on cost function in machine learning with example by IntelliPad. In this session, we'll try and demystify the concepts of cost function in machine learning. Cost functions are one of the most important parts of any machine learning system that we are going to build in order to train a model, but it's often quite misunderstood and difficult to understand. Keeping that in mind, we've come up with this session in which we'll take a look at what cost function is and how you can implement a few of those cost functions on your own from scratch using Python alone. So let us begin with this presentation by taking a look at the agenda. But before we do so, we'd like to ask you to subscribe to our channel and click on the notification bell icon to never miss another update. Also click on the like button if you liked this video and put down in the comments what other technologies you'd like for us to cover next. Also, in the meanwhile, if you have any questions regarding whatever we are covering in this session, put them into the chat box and our team is there to help you out. And if some of the things that we're discussing doesn't make much sense to you or is over your current skill set, don't worry. We'll guide you through some of the resources at the end of the presentation through which you can learn more about these technologies. So let's take a look at the agenda. We'll begin by taking a look at what is a cost function, since that is the basis of what we're trying to cover here. We'll then move on to take a look at why should you use a cost function. Then we'll take a look at the types of cost functions that are available to us. We'll discuss each of them and we'll try and get a good understanding of how they work under the hood. And then we'll have a hands-on of cost functions in which we'll use Python to implement these cost functions on our own. For following along, all you would need is some environment where you can run Python. It could be Jupyter Notebook. Preferably, it should be a Jupyter Notebook because you can run the code, immediately see the output as well. Or you can use Visual Studio Code and just write the code and run it in a command line. Or even you can use an IDE such as PyCharm or any other IDE. So let's take a look at what is cost function. What is cost function? A cost function is at the heart of what we're trying to discuss here. So let's discuss. So a cost function is also called a loss function. This is a concept in machine learning especially, but more generally it's a mathematical function that is used in machine learning to quantify the error produced by an ML model. So if you have ever tried to build a machine learning model, the way it actually works is that you get some data set, and we're talking about supervised learning, where we have data and we have the values that it should predict so that the model can learn from that. So what happens is we get the model, then to train the model we need the data. The data needs to be cleaned and of high quality. After getting the data, we separate our data set into training and testing set. Training set is the majority of the data, let's say around 70%. Testing set is 30%. So we train our model on the data that we have set aside for training. Now comes the time that we have to evaluate our trained model. We need to figure out whether or not it learned something and what is the accuracy of the model. Now, if it's a simple classification problem, for instance, if I'm showing an image and I want to say whether or not this image contains the face of a human being inside it, then it's either going to be a yes or no. It's called a binary classification, and I can simply just take a look at the predictions and the actual values. So if I show it a photo and it says that there is no face in the photo, but there is a face, so that's misclassification and we can leave that. And if it predicts it correctly, then that's a correct classification. So we can just figure out how many correct classifications were there and figure out the percentage. It's a little more complicated in regression. If you've ever used supervised learning for regression, basically you're trying to predict a number using some features. For instance, you're trying to predict the price of a house using the features such as the number of rooms, locality, area, crime rate, and other aspects as well. So after you have predicted the house prices, how do you figure out whether or not the house price is correct? So you already have the correct house price of it. You take the predicted house price and then you compare the two. If it's not the same, then how far away is it? And if you're predicting multiple of these, as we would in a testing set, we have around 30% of the data for it. So we would predict for all of those. What would be the output of that, and how do we figure out how far away or how wrong our model is? How do we quantify that? So this is where our cost function come into play. They help us do exactly that. Now, how does that happen? We'll take a look at that in a moment. So why would you want to use a cost function? Let's take a look at that to understand why. The cost function is quite useful as it allows us to quantify the magnitude of error produced by the predictions made using a model. So if you're trying to make a model, you would have to make some predictions and you have the actual values with you. You compare them to the predicted values and then you figure out what the error is. error is the difference between the two. Now, if you have multiple of these predictions and you want to figure out an average of those errors, then you would have to perform some kind of mathematical operations on these errors in order to figure out how far away is your actual model from the real world predictions. How badly is it performing? And after quantifying that, we can even compare two models. So if we have two models that are using different algorithms or different kinds of data structures, we can then use this cost function, figure out the cost of model A, cost of model B. Whichever one produces the lower cost is the model that wins. So that's basically why we use cost function in order to figure out what is the magnitude of the error produced by a machine learning model. This model is trained by us, so we need to firstly figure out how to get the data into it, make the prediction, and after making the predictions, only then does the cost function come into play. Let's take a look at types of cost functions. So there are three main types of cost functions: MAE, MSE, and RMSE. You can find other cost functions as well, but these are the three main types. So these are acronyms, they stand for something. Let us discuss them one by one. So MAE stands for mean absolute error. These words actually describe what the error is. So for instance, if I have MAE or mean absolute error, the formula is being displayed on the screen right now. What we want to do is, for all the observations that we have, we want to take out the absolute difference between the observed value and the expected value, and then we want to take out the mean of that. So we want to get the average of the absolute error. That's the mean absolute error. That's why it's called mean absolute error. Let's take an example. Suppose I have a model, and for three observations it predicted -3, 0, and 3, while the observed or the actual predictions were 0, 0, and 0. So if I were to just take the error, it would be 3, 0, and -3, which would be observed minus predicted. So 0 minus 3 would be 0 minus minus 3 would be 3. 0 minus 0 would be 0, and 0 minus 3 would be minus 3. Now the problem is, if I were to add all of these up and then take the average, the error would be 0, because -3 plus 3 is 0. We add 0 into it, it becomes 0, and then we divide by it, we get 0. The error could be solved by getting the absolute error. So if it's -3, we'll just turn it into positive. Drop all the negative symbols basically. So we get 3, 0, and 3. So after getting the absolute error, we need to figure out the sum of the absolute error, which in this case is 6. So we figured that out. And then we finally divide 6 by the number of observations we have. Here we have 3 observations. So the mean of the absolute error that we have calculated, or the mean of the sum of the absolute error, is 2, which is 6 divided by 3. Similarly, we have mean squared error. So just as we have discussed mean absolute error, we can also discuss mean squared error. This is also quite easy to understand. All we have to do is we need to figure out the mean of the, instead of calculating the absolute error, we need to calculate the square of the error. So basically it means for all the observation from 1 to n, get the observed value, get the predicted value, figure out their difference, and then square them instead of getting the absolute error, and then figure out the mean of that. So if you were to take a look at that, it's the same thing here as well, but instead of getting 3, we're getting 9 because we're squaring the error. The reason why is because the larger the error is, let's say it's -15, when we square that, we'll get even higher number. So as the error increases somewhat, it would increase exponentially. So squared error is going to make it seem like the error is going to be absolute. So now let's take a look at the sum of squared error, which is going to be 9 plus 0 plus 9, which is 18. So we get 9 plus 0 plus 9, 18, which is the sum of the squared error. The error is calculated the same way we did earlier. We take the observed value, subtract it from and subtract the predicted value from it, then we get the squared error. So now we get the mean of the squared error, or mean of the sum of squared error, which is 18 divided by 3, which is 6. So as you can see, this is just simple mathematical operations, but the understanding here is that we want to account for negative errors, the magnitude of the errors, and so on. And then comes root mean squared error. So basically the same thing that we did earlier, but we need to calculate the under root of the mean squared error. So this is it, square root of the mean squared error. So we get the numbers, we calculate the square, and then what we do after calculating the mean squared error is we calculate the root of this. So root basically means raising a number to the power of 1 divided by 2. Basically the output of this would be 2.45. Now the reason why this is done is, even though we want to make sure that the errors that are higher get higher penalties, after all of that, if the number is really large, it's really difficult to deal with. So let's say that we are calculating error for a million values, and for all of those the error is somewhere around 15. So the square of the error is going to be a really large value, and then we sum them all up, and then if we have to deal with that error, it's going to be really difficult for our computer to work with that. We can also we can take the square root of that. It will still observe the same values. It means if the numbers have higher errors, they would still be penalized highly, but at the end of the day we get a smaller number to represent the magnitude. So that's the way it works. Now which one should you use depends on how you want to do it. If you want to tax numbers that are higher than the others, basically if you have an observation on which your model is giving you high errors, then you can use the mean squared error. If you want to tax them but still want to keep the number small, then there's root mean square error, and mean absolute error is good as well, but it's not that much used. So now we have come to the hands-on, as we have already discussed. To follow along with the hands-on, you don't need to do much. All you have to do is have Jupyter Notebook installed with you. So I already have it installed and I have it running. I'm just going to open it up. This is what it looks like. To make sure that the Jupyter Notebook that you have is working, just type print and print anything. I'll print hi and see if it's working. If I get the output, let me just expand it a little. Here we go. So now let's take a look at how we can go about building the entire function. So I will create 3 functions for this. First one is going to be mean absolute error, MAE. This will take in 2 things. And by the way, this is all going to be implemented in Python completely from scratch. So you don't need any libraries installed. We will need the predictions and the actual values. So the predictions contain the predictions made by the model. Actual values contain the values that were supposed to be predicted by the model, and the actual values represent the actual values. So now what we want to do is, as we have already discussed, for mean absolute error, firstly we need to calculate the absolute errors. So let's say absolute errors. I'll create a list of it. I can use list comprehension. Let me just show you. I'll just use absolute of x minus y for x comma y in zip, and I'll zip these two. Now if you don't understand what I'm doing here, don't worry, I'll explain more in detail, and we have some resources planned for you so you can take a look at those and understand how it works. So you get the absolute error. So it works right now. There's no syntactic error here. Now after getting the absolute errors, I want the sum of that. So I want sum of absolute errors, and for that all I have to do is do sum. Python makes it really easy for us, of absolute errors. And now I want to return the mean of absolute error. So return, and for mean all I have to do is take the sum of absolute errors divided by the length of absolute errors. Run this. Now if I want to check how this works, I can just type in MAE, and I will, for the predictions, I will type -303, and for the actual values I can type 0 0 0, the same example that we had earlier, and the output is 2. So it is what we expect it to be. Now in case this comprehension seems a little too daunting for you, let me just do it again for you, but this time I'll do it in an easier way. X comma y in or I can do it even easier, for index in range 0 to length of predictions. Now x would be equal to predictions of I, y would be equal to actual of I, and error would be equal to absolute of x minus y. And then for absolute errors I want to append it to error. Run this, and I think we run into some errors. I is not defined for, oh sorry, for index. I'll just call it I. Yeah, so we get the same output. So basically this is what's happening. We're creating a new list in which we are going from the prediction of over all the predictions. We're taking the prediction and we are taking the corresponding actual value. So for first instance, we're taking -3 as the x and 0 as y. We go down, we say -3 minus 0, it's going to be 3. Get the absolute value, put it inside our absolute errors, so we get 3. Then we get 0, then we get 0 minus 3, which would be -3 again. Absolute value of -3 is 3. Append it, so we get 303 inside it. Then we sum it up, which is 6. And then here we get 6 divided by 3, which is 2. So this is how we're getting the output. Now, I think you can probably agree that even though that works this way, this looks much nicer. It works really well and it is much more succinct. So I can just do it in one line instead of 5 lines. And I can even reduce this entire thing into just one line if I want to. I'll show you how to do that later on, but this is how we can do this. So this is how we get the mean absolute error. Now let's implement the other one. So mean squared error, we need the same thing. So predictions and actual, I'll just copy and paste. So we get the prediction, we get the actual value. Now I want these, instead of getting absolute errors, I want the squared errors. This is the only thing that's different here. So again, I'll use the same thing, but instead of getting the absolute value, since we don't want that, I want the square of that, which is this. This is how you get the square. Now I just have to do the same thing that I had done earlier for x and y in zip. I'll also show you how you can implement it in just one line. But right now you can just do it in actual. So after getting the squared errors, I want the sum of squared errors, which is going to be sum of squared errors. Finally, I'll just have to return the sum of squared errors divided by the length of squared errors. Now I do the same thing I have done earlier, but instead of calling it mean squared, I'll call it mean squared errors, and I get 6, which is the output that I was expecting. So after getting that, after getting 3 and 3, we get 9, and we get 18. 18 divided by 3 is 6. So that's the output that we're supposed to get. Now we have to determine root mean square error. Again, I have to do the same thing. So as you can see, implementing these things are not a very difficult thing. You can just do it easily. Again, I'll show you how to implement this in a single line as well. So again, I have to do the same thing. SQUARED, squared errors, x minus y multiplied raised to the power of 2 for x comma y in zip predictions actual. After getting the squared errors, I want the sum of squared errors, and then all I have to do is return the sum of squared errors divided by the length of squared errors, but I have to get the square root of it. So I can just multiply it or raise it to the power of 0.5, and that would be the same thing. So Rm, I'll do the same thing here, but RMSE, and we get 2.4549, but that's exactly it. So that's the output that we get. Now again, if I wanted to do this, I could have just reused the entire functionality, mean squared error, and I would have passed in this so that I don't have to copy and paste the code, and I would have gotten the same response. So I'm just getting the square root of the mean square error, which is exactly what a root mean square error is. So let us see how we can implement it in even more succinct fashion so that we can understand how to do this easily. So I'll just inline this. So instead of it being this, I'll just sum it up. Now there's no need for that, and then I'll divide it by this. There you go. And oh yeah, length of absolute errors is not going to work because we have removed absolute errors. So what we can do is we can use predictions. Now does it work? Yeah, it's working. It's the same thing we can do here as well. Let me just show you. So sum this up divided by the length of predictions, and then just return this, and we get the same output. Now here again, I have just implemented it in this one line, but I could have done the same thing here. So if I hadn't implemented mean square error, but I wanted to implement root mean square error, I could have just done this in one line and then raised it to negative, and that would have been the output. So as you can see, this is done in Python because it makes it so easy for us to do. I can just write one line of code and everything is going to work exactly how we want it to work. These comprehensions and all of this, these are features available exclusively in Python, and that's why these are so important. So with that, now let's take a look at how we can learn these things, whatever we have described. Just for a recap, for the mean absolute error, we took the absolute of the all the errors that we could find of the predictions and the actual value. We figure out its mean, and we returned the output. Similarly, for mean squared error, instead of getting the absolute error, we get the square root of the error. And for root mean squared error, we calculated the under root of the mean squared error. These are the outputs. All right. So now let's take a look at how you can learn these things to get a better understanding of all of these topics. Now we'll take a look at what we have discussed so far, and we'll take a look at how we can learn these things. So an investment in knowledge always pays the best interest is a quote that always helps me stay motivated when I'm learning new things. So if you are trying to learn a new technology and you run into some errors, if you run into some problems setting up the technology stack or working with the technology, we have a community site which is located at intellipaat.com/community. You can visit that site, create an account, and post your questions. People who are at the same, your peers, can help you out with the problems that you have faced. Maybe they have already faced these problems, or maybe they know how to deal with these problems. So you can take a look at that. We also have a blog, intellipaat.com/blog, where we publish content regularly. You can take a look at those blogs and gain even more knowledge and in-depth understanding of several other technologies such as computer vision, machine learning, cloud computing, data science, programming, web development, and many others. If you're more of a visual person, we have a YouTube channel for you as well. You can take a look at that and understand how you can learn new technologies. We have free courses available on YouTube channels ranging from Amazon Web Services, cloud computing, data science, machine learning, web development, and many other technologies. So you can take a look at that as well. In case you don't want to get free courses, but you want to get certified in order to demonstrate your capability as a particular professional, then you can visit our website. In case you wish to learn data science and machine learning, as we have discussed, you can take a look at the Masters in Data Science online program. This is available for you, and it is built in collaboration with IBM. You get 10 plus courses and 53 plus projects. These projects are going to be incredibly helpful for you. The reason why is because after you are done learning these things, you need to demonstrate that you know these things, and projects are a great way of doing that. And projects are one of the main factors that separate people who are chosen for interviews and those who are not. So you can take a look at these projects as well. We discuss data science with R, Python, machine learning, AI, and deep learning, big data, data science with SAS, and there are 3 self-paced courses for advanced Excel, MongoDB, and MS SQL as well. You can see we can cover the entire spectrum. We teach you everything that you need to know from ground up, so we don't expect you to know anything at the beginning. You can take a look at the features and the courses included in this bundle. There's instructor-led training, self-paced videos, 24/7 live support, certification and job assistance, and flexible schedule. We have our entire course bundle listed here. You can take a look at all the courses available. You can take a look at the testimonials to see how the people have rated this course. This is one of our most highly rated courses. You can take a look at the course content as well as to understand what each technology is being, what in each technology is being taught to you. You can take a look at the certificates. You'll get 2. First one is from IBM and second one is from Intellipaat. These certificates are valid in several multinational corporations such as Nasdaq, Ericsson, Sony, Cisco, and others. You can get the online data science master's program FAQ down at the page that will answer a lot of the frequently asked questions. In case the question that you are looking for is not answered here, let me guide you through a resource where you can get the answers for that question. But before that, thank you so much for joining us. Here's a coupon code especially for our YouTube viewers. It's YouTube30. In case you wish to buy a course from our website, and you get a flat 30% off if you use this course. Use this coupon code on any of the courses that we provide. So this Coupon code is going to be available for a short period of time. We hope you make use of it as quickly as possible. With that, we've come to the end of the presentation. We have these numbers listed on the screen in case your FAQ, if your questions were not answered in the FAQ. And if you have any other queries that you would like us to contact you with email, then you can contact us on the sales@intellipad.com mail listed on the screen. Our course advisors are there to help you out 24/7 and help you guide through a career trajectory that's most helpful for you. With that, thank you so much for joining us, and we'll see you next time.